Find the positive value of x such that log to the base x of 64 is equal to 2. So the base is x, the power is 2. So this is the same thing as saying x squared is equal to 64. The base is x, the power is 2. So these two statements are identical. But by writing it in this form, I can see quite clearly that x is either equal to positive 8 or negative 8, and I need to give the positive value, so x is equal to 8. Part B, I need to solve this equation. So what I want to do here is to group up all of the x terms together. So I'm going to move this log term over to the left-hand side to be with the other x term. I'm going to leave the 3 where it is for now. Now the next thing I'm going to do is I want to bring these two logarithms together using the laws of logarithms. In order for me to do this, I need to deal with this power first, or rather the coefficient, but I'm going to make it become a power. So I'm going to move that 2 up to be a power here. Now I can use the subtraction law. So I can combine these two logarithms to be 11 minus 6x over x minus 1 squared. Now I've got the logarithms together by themselves. By itself, I can remove the logarithm by doing the inverse of a logarithm. The inverse of log base 2 is 2 to the power. So if I do 2 to the power on both sides, 2 to the power log base 2 cancels out and just leaves me with the 11 minus 6x over x minus 1 squared. 2 to the power 3 is 8. I'm now going to multiply both sides by that quadratic to get rid of the fraction. I'm going to expand the brackets out. And move everything onto one side of the equation to get 8x squared minus 10x minus 3 equals 0, which I can then factorise to be 4x plus 1 or 2x minus 3. So I get two solutions. Either x is minus a quarter from this first bracket, or x is equal to 3 over 2 from the second bracket. I just need to check whether they are both valid solutions or not by comparing them back to the original equation. So if I took minus a quarter, if I substituted that here, that would cause a problem, because I'd have minus a quarter minus 1 would be minus 5 over 4. It would be negative, and I can't do log of a negative number. So this is not going to be a valid solution, so I'm not going to give that one. This though, if I checked that, if I substitute that into there, 3 over 2 minus 1 is a half, and that's positive, so I can do that, that's okay. Substitute 3 over 2 into here, 11 minus 6 times 3 over 2, again that's positive, that's okay. So this is the answer to this question.